Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with DevExpress controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I am talking with Camille Eddy. She is a mechanical engineering intern at a mysterious company called X. I think it's part of the alphabet, and but it was also a machine learning intern at HP and worked on robots there for a couple of years as well. How are you?
I'm good, thank you.
Your LinkedIn is way cooler than my LinkedIn, and it's very nicely curated. I'm actually going to use your LinkedIn as the guide to update my own. You have done a ton of cool stuff.
Thanks, yeah, it's been fun.
So your focus has been, looks like it's kind of split in the sense of it's robots and electronics and mechanical engineering, but also machine learning. Are those separate things, or are they the same thing that work together?
I like to think of my kind of career path as the idea of integrating machine learning with robots. So it's bringing the hardware and the software together and being able to straddle that middle line and look in both directions and see what's coming down the road.
Does that mean that you have to do like double the work? Because I know people who do robots and they think about soldering electronics and firmware, and I know people who do the software for them but never have to touch the physical robot. You're in the middle.
Yeah, I don't think I have to do double the work, but it does allow me to kind of look at the ideas as they're coming down the pipeline and start looking at how we would implement them. So, sometimes I do work on teams though, where, especially like at HP, someone would also come in and I say, this is my vision, and they'd help me kind of get there. And I'd focus maybe more on the hardware part while they're focusing more on the software part. So, it allows me to still be able to direct some of the vision, even as an intern, as a very young engineering person, but, be able to help and then also focus on my expertise, which is hardware and mechanical engineering.
And you have a degree from Boise State, but it looks like you've gone to schools and visited schools like MIT and participated in different undergraduate programs and worked at multiple schools.
Yeah, actually, I don't have my degree yet. I'm still in the process of getting my degree. But yeah, I'm really big on traveling. Idaho is a pretty small place. It's definitely an isolating place. So I take advantage of every opportunity. I get requests to speak somewhere, or I'll apply to a program, and I'll definitely take the opportunity to go outside of my community and explore. And I found a lot of friends that way, and then also learned a lot. I don't think I really would have learned about culture bias or artificial intelligence and robots if I had just stayed in my one community where, it's pretty self-sufficient. So being able to go outside my community, learn from others, hear other stories, that's been really helpful.
That's a really good point. So let's talk about that. Let's talk about going outside your community. So, I'm in Portland, Oregon, which is a certain flavor of town, and you're in Boise, which is even more intensely a certain flavor. What kinds of cultural bias does one bump into when they're living in a small town like that, and how does it affect your life?
Sure. So very small changes tend to make really big ripple effects. So for example, Boise, Idaho, and the general area around Boise is a refugee relocation site. So refugees, when they're coming to America, Boise is one of those places that they're dropped off at. And so that for that reason, we have a really large refugee population. But Boise is one of those places where the African American population is under 2%. So for us, we start to see differences in how people interact with us. So even if I'm walking in a coffee shop, I can notice some of the stigmas around being a refugee because it's directed at me. People will think that I'm a refugee. And so, not that that's bad, and I would totally wear that mantle, but you can start to see where people are like asking you if you know more than one language, asking you what country you're from, different things like that pop up a little bit, more often. And it's because of that just kind of slow ripple effect. But that also provides the opportunity to do, really great community outreach. So at my school at Boise State, we noticed the problems. And so one of the things we did to help welcome more people was actually change the name of our club. It was the Black Student Union, and it became the Afro-Black Student Alliance. And so there we recognized the coming together of two cultures, the African American culture and the African culture. And that's been really helpful to bring a sense of identity for all students in our schools that have that African heritage. And again, it makes small ripple effects because from there, now we're visible, we're taking up space. And I think that's helping at least our small community within the university have a better, more inclusive atmosphere.
Now, someone might hear that story and think, oh, well, I mean, come on, she changed the name of a club from one thing to another. Did that make a ripple effect? Did people notice and say, wait a second, maybe I could join? Did you have, allies and accomplices join? And did you have Africans say, oh, I didn't realize this was for me because Black meant African American, but now I realize that it is for me, and then come and join your club?
Yeah. There's this thing about identity and being able to just recognize someone's identity and say you belong as you are. And we definitely, the club itself was feeling this divide and this polarization where we would walk past, like me, an African American student would walk past an African student and we wouldn't say hello to each other. We wouldn't talk to each other. In fact, there might even be a little bit of animosity and ignoring each other. And so this small thing helped us bridge a gap between cultures, and in a way that said you're welcome with your identity, and you don't have to take on like the African American identity if you don't want to. You don't need to assimilate to this. You can still retain kind of your identity while being a part of a greater community. And I think that really helped us all, because then also myself, right? As more students are coming in, where do I belong? Do I still belong as an African American student? So I think both sides were able to kind of grow together.
And hopefully you get to the point where there's a goal where everyone talks to everyone and when they walk by and respects where they came from and their identity, and everyone can walk into a coffee shop and, feel comfortable.
Exactly. And they don't have to feel like there's some type of like puzzle that's too hard to solve. Like, who are you? Like, does it matter? No, actually it doesn't. We're actually just having great times, and we all have similar interests, and we have ways that we can learn from each other.
So I'm imagining the person at the coffee shop, okay? And I'm imagining them as a machine learning algorithm, and people are coming in and they are training their algorithm and developing biases that they might have based on a person comes in and they say, oh, brown person, do I have to deal with their accent? Do I have to, who is this person? Where are they from? They're building a model in their minds. And then, of course, you open your mouth, which gives them additional data that builds their model. Is that a reasonable sense of what a machine learning model might be doing if it were a barista at a coffee shop?
Yeah, I kind of like that. There's definitely this conversation about data sets and how diverse are your data sets. So, in a more machine learning type example, I remember I went to a conference in San Francisco and there was, an engineer from Pinterest, and he talked about how he had built a model to recognize boats. And that's what it was supposed to recognize. He had a smaller data training set, and it wasn't as effective as when he added a lot more points to this data set. So maybe he had 100 and he added 1,000 to this data set. And then he started to see an increased familiarity with these objects so that it was even more correct and it was spot on. So going back to the barista idea, not having exposure to other cultures and other accents might make it more of an ordeal. Like, oh, this is unfamiliar to me. I don't know how to understand their intentions. I don't know if they're happy or sad or if they're, impatient. But as they gain more exposure to them, then they can be more realistic in their guesses. Like, oh, I've seen this before and I've interacted with them. We've had great conversations. We've had bad conversations, but now overall, I don't walk into it with, the wrong preconceived notions, because we all have preconceived notions about each other. That's not going to change. But what can change is if we're wrong about our guesses.
I feel like you and I are developing a very effective extended metaphor here, because I really am starting to think that this works. I've had situations where I've come into contact with folks in my wife's family. My wife is African, and I felt like, gosh, maybe Uncle so-and-so doesn't like me. And then my wife will be like, no, that's just him, right? And then you meet more, to be a generalist here, you meet more African uncles and you go, oh, okay, well, that's how Zimbabwean uncles act. Or I've met 100 now, 1,000, 1,200 over the last 20 years. And I go, okay, I'm pretty sure that I have a good data set of how people act and how people behave, so that I'm not going to necessarily assume that one bad interaction ruins the data set.
Absolutely. Yeah, that's brilliant.
Yeah. That's interesting. Okay. So then when thinking about machine learning and then applying it to things like cultural bias, if you have a small data set, what kind of bad stuff can happen when you're training an algorithm?
So some of the things I've seen pointed out before are you'll be wrong, of course, about your guesses. So it will overreach. Another example of overreaching, though, besides just being wrong, is making the wrong assertions. So there was an example of this training set called Word2Vec, and it was actually a training set that was used on the Google News posts from a certain time period. And they wanted to ask this training set, about the information it had taken in from Google News. So it got all this data from Google News, like they imported it in, and they asked it a basic question like, man is to computer programmer as woman is to what? And it answered homemaker. And this is actual training set and a story that you can look up online. But the answers that it gave were inherently sexist. So it overreached into its answers were too simplistic, It was interpreting our own language, our English language, and the way we write and talk in the news, to have an overtly sexist meaning. And that is a very interesting problem when you're not necessarily trying to hit, the wrong answer, but you inadvertently do that. You mistakenly make a social taboo, or you're not as progressive as you think, or you're making choices that you don't understand why you're making them. That's kind of what can happen if you have a limited training data set.
Interesting. So what about that legendary joke? This sounds like that legendary joke where someone says, a boy is taken in for an operation, and the surgeon says, I can't do this surgery. This is my son. And then we all go like, oh, how is that possible? It's like, well, the surgeon is a woman. Historically, that may have been true. That's why a riddle or a joke like that would work. And then if you take a large enough data set that makes that true, but it isn't ideal or it is inherently sexist, how do you resolve it is, it has historical truth or some historical truth, but it is definitely not cool. And it's not the kind of society that we want to build. How do you answer people who might say, well, but I can kind of see where that's true.
Right. I think that's where signaling comes in, like where you say like what your standard wants to be. And that's a tricky part. That's where people might not
Can you explain signaling? I don't understand what that means.
Yeah. So signaling is saying, I'm taking a stand. This is the line in the sand that I'm going to draw. And I want to be on this side of the line. I want my world to be better. And that's where I think the power and the influence of engineers come in, is because we're creating, paradigms, we're creating trends before it even goes out to mass distribution, before it even goes out to the public. How I design my product to interact with someone's culture or with someone's biases is going to set it's actually maybe even going to set what truth is for the next 10 to 20 years that my product is going to be used based on how my product is interpreting information and using information and giving that to people because we believe what we see. So that's where you can signal and say, this is what I want life to be. And that's where people get, iffy, like that's tricky. You're setting ethical standards that maybe I don't necessarily agree with. But I think it's something that even if we don't like that we have to make that choice, we shouldn't act like we're not making those choices every day. We are making choices about who we're excluding and including every day. And it's better to go into that intentionally versus just letting whatever happen.
Okay, that's a very good explanation. So then signaling is imposing our ideal scenario, our belief system onto the model and steering it correctly. It might go and determine that, babies are a great source of protein or something bizarre like that, which may or may not be true. And babies are cute and I want to eat their cheeks, but still we know don't eat babies.
Right. We have our own standard and our own filters for what's right and what's wrong. And we can still impose. I
heard two good examples of machine learning gone wrong that I thought I'd run by you. One of them was someone trying to train an image recognition system to figure out Russian tanks versus U.S. tanks. But then when they did it out in the real world, it failed. And it turned out that all the pictures of the U.S. tanks were taken in the daytime and all the Russian tanks were at night. So all they did was teach the thing how to tell day from night.
Yes. Oh, that's a wonderful example. Another example I heard was University of Washington. Their mascot is the Huskies, and they had researchers that wanted to detect Huskies from dogs. So they put it through an algorithm test and it was super accurate. And so they said, oh, this is a Husky, this is a dog, and it was correct. But then they came to look at what it did to make those decisions, and they found out that they had made a really good snow detector. If there was snow, it was a Husky, and if there wasn't, it was a dog.
See?
Yep.
Yeah, that's another one that's the same exact thing where they were training the subway platform to see whether it has people or not, but they forgot that the wall clock was visible, so they just taught the model how to read the clock.
Wow, that's amazing. So that leads into transparency, and that's transparency in AI is actually an up and coming technology. You can think of it as a technology now, and what it seeks to do, what this particular technology seeks to do is to understand why your algorithm makes the choice that it makes. So the example I usually give when I'm giving a talk is I'll take a picture of a speed sign. And say you have an image recognition software that's using machine learning and it's supposed to detect the speed sign. And how it works is it breaks up the speed sign into recognizable parts. Like I recognize the font, I recognize the bold lettering, like the black on white, I recognize like the general layout of it. I recognize that there's a 5 and there's the word speed. So these little parts are broken up and put into this, think of it like a database. Then it makes a prediction of whether it's a speed sign or it's not a speed sign. And from there, you get an accuracy. Like, so this many times it guessed the right number, it has this amount of accuracy. So what explainable AI does is it seeks to pull out that database, what it used to make those choices in order to say that it was a speed sign or not. And that's really important. Something that we haven't really thought about as of yet is why did our algorithm make the choice that it made? Why was it affirmative? Why was it negative? And sometimes, like in the examples we just showed, it's not actually basing it on what we think it's basing it on. And it can still have a great accuracy, but not necessarily be detailed on the details that we want it to be.
Okay. So if I understand that correctly, right now we think of AI and we the non-machine learning experts like yourself, me, just regular programmer. It's like there's a function and there's a giant brain that I don't understand and I tell it stuff and a true or false comes out, right? It's very mysterious. It's very black box. This is a cat. Okay, computer, all-knowing computer. Thank you for the information. That is a cat. It's totally not a cat. Right? Yeah. So then you're saying explainable AI would be like, it's a cat. It's got fur, it's got whiskers, it's got claws, and it's got those pointy ears. That's why I think it's a cat. And then we could say, well, you were close, but not really. Which really means it's like we're teaching little children.
Exactly. And one of the ways that it can be used today is actually in social media, because we interact with algorithms all the time on like Facebook, on Instagram, on Google. And what they could do here in transparency is actually show users why they see the search results they see. So for example, on Facebook, we tend to think what's on the internet is true, right? But as in the case of all the recent right? As in the case of all the recent elections and the stuff that were going around there, what if we knew why it popped up in our feed? What if we knew if it was something, it was an ad, if it was paid by a certain organization to show up in our feed? What if we knew that it was because we're friends with this particular person and this particular person likes this? If we could control those levers a little bit and say, well, instead of just offering me, like, for example, on Google, instead of just offering things that reiterate my own worldview, go ahead and offer me things that challenge my worldview as well, so that I can see that. Because we know that as we click more on social media, on Facebook, on Google, it's trained to give us more of what we want to see. But we can maybe change it and say, like, give me more of what I don't want to see. Give me something else. Give me something based on my geographical location versus not my geographic location. Things like that.
Right. That's really interesting. So I know as I travel and I know as I go on Amazon and I look at stuff and then I find Facebook trying to sell me that stuff, I can, as a non-technical user, determine that, okay, it must be showing me nails because I was looking at a nail gun on Amazon. Like I can figure the causality there. But like lately I've been interested in climate change, and I believe that, we humans have caused climate change. We've done it. So then I noticed that all of the things in Facebook are agreeing with me, like you said. I'd be interested in a challenging article that said, here is the science against climate change, but not like a big fake news article about someone's rant and opinion. I would like a legitimate, there must be a scientist who doesn't think it's the case.
Sure.
If they could offer that and tell me, this is a challenging point to your view that, why are we not seeing transparency in AI? You're describing exactly what I want.
Exactly. I think it would be really fun. I think it would get people to engage with the site even more, because then they're also fine tuning their choices and looking at it. And I got this idea from Eli Pariser, who gave a brilliant TED Talk, on filter bubbles. And so he talks about this idea more. And I really suggest anyone interested in this idea more to go check out his TED Talk.
I will add a link to Eli Pariser. He is the chief executive at Upworthy, which is a place that has used AI so smartly that they created a huge amount of viral content.
Right.
Interesting. Yeah, I feel like, you think we're moving to that world? Are we going to get this level of transparency, or is there a reason for them to not give us transparency in AI?
I think it depends on how viral Eli's talk goes, right? I think these are ideas that live in these bodies and lives in the people's minds. And if they're not if they're not where they can influence these decisions at these bigger tech companies, and again, we're right back to technology being used to influence the future world, to be able to draw that line in the sand, to signal. If we don't have people right now in our technology companies signaling this is the side of the line that they want to be on, it's going to be really hard to see that happen, because you don't have these ideas up there. So that's why it's really important to not only have, your developers be diverse, your executives be diverse, but also your users to be diverse, and to give that feedback. If we could somehow make this pipeline and this feedback loop really short and more effective, then we could see that happen. But it really depends on where these ideas exist and how much influence the people who have these ideas actually have to change the world around them.
I saw a video on Twitter where it was a Nigerian guy who was in a bathroom trying to dry his hands. And I was watching it, and the dryer wasn't turning on. And I was like, what is this, some kind of prank? And then out of the side of the frame, a white guy's hands came in, and it totally worked.
Right.
And then the Nigerian guy tried to do it again, and it didn't work. And, as a white guy with white hands, it took the white guy doing it for me to go, whoa, that's a problem. Because I can't personally, I'm sure that's the fact that none of us can get the water thing to work. Like, I've never been able to get we just know those don't work for anyone. Sure. But from the dryer's perspective, I've never had any problem at all with automatic dryers. Is that a trained model? Is that something that was a lack of user testing?
Yeah, I think it depends, right? So light reflects maybe off of your skin different than mine's as a Black woman. And, but there's definitely cases where different, the way you develop and the science that's behind it, right? The physics and the lights interaction is different. And so, maybe they didn't have a diverse, physical user base to test to see, in poor lighting, will this work as well? A really cool researcher named Joy Blawamina, she was at the MIT Media Lab. She had research where she was trying to work with a social robot that uses a facial recognition camera. And she's also a Black female in research, and she wasn't able to be detected by her own experiment. It wouldn't recognize her face, and so she actually had to wear a white mask in order to complete her research. And she actually shows a video. Her website is called the Algorithmic Justice League. Very cool website. And she shows a video of the example of where she sat in the camera's view, without the mask, and then put the mask on, and then it detected her. Or one of her colleagues would sit in the camera, her white colleagues would sit in the camera. It would detect them, then she'd go into the camera view and it wouldn't detect her. So these kind of examples pop up every once in a while where something just doesn't connect, and it creates a different experience for people who have different skin tones.
Yeah. When the Microsoft Kinect first came out many, many years ago, my kids were maybe two or three. None of my family or my brown kids could be seen by the Kinect. But then a call went out for a more diverse user base. They retrained the algorithm. It wasn't a hardware issue. It was an algorithmic issue. And now the Kinect works just fine. And we have things like the iPhone X, which has facial recognition, which I'm sure that in today's world, they probably did a lot of testing on all kinds of people.
Very interesting problem, yeah. And I'm glad to see that they seem to have looked at that case scenario. And another example is when there was an example in Google Photos. It was one of their apps, and it was built, like Facebook and other Google apps that detects faces, and it accidentally detected this one person's face. It was an African-American male with an African-American female, and it detected them as gorillas. So instead of grouping them as people, it grouped them with the header and the tag gorillas. And that's like a really big faux pas. And one of the ways I kind of came to understand that problem was it couldn't understand that even though they had darker facial features, that it wasn't to go into this category. And that again goes back to having much broader training sets. Even if you have a couple of people of color in your training set, that might not be enough. You really do need to take a better look at expanding your data sets. And then, so when I usually say that, I get questions like, well, that still seems like, that might be too much. Like you're having to really reach for that. And again, it's about signaling and saying like, hey, this is actually what we want to do. We want to provide a great experience for everyone, and we don't want this to happen. So instead of just figuring our ways around this, so for example, the initial fix for that issue that I just described was to remove the gorilla tag from all photos, so nothing could ever be tagged photos. But instead of doing that, we can actually be intentional in how we expand our data sets and being able to provide that great experience for everybody.
Right. That might be the appropriate PR maneuver to shut it down immediately.
Sure.
But you're right. The right answer is a data set. And with a sensitive issue like that, and in fact, my friend is the gentleman who had that happen, my buddy Jackie. So I know Jackie, I know about this situation, and this became a big deal in Google Photos a couple of years ago. And you have to be careful when you're an engineer, don't you? Because you could say, well, actually, I can see because of the low contrast and the color, I could see where, might think that. I mean, they clearly look like humans to anyone, but you can see why the computer thought that. So it would be nice to have then that explainable artificial intelligence to tell you why it thought that. But there are certain things that you just can't do. There are social mores, like you said. It's just a line you don't cross, and that's a good example. Didn't Chrissy Teigen see a weird thing recently with AI? Did you hear about that?
No, can you tell me about it?
So Chrissy Teigen is John Legend's wife.
Right.
And she is a kind of a geek, and she does all kinds of cool geeky stuff. And she was goofing around in her Apple photos and discovered that she could search for brassiere and found all kinds of awkward photos of her like getting dressed and trying on outfits and stuff like that. But the word bra had 0. So she started to think about maybe they've blocked the word bra and underwear and the kind of the obvious stuff, but they didn't mark the full word brassiere. And then people confirmed that and went out and said, oh my goodness, if I search for brassiere, there's all these pictures of me getting dressed and trying outfits on. And like, I don't want those kind of photos to be, searchable. Why is bra not available, but brassiere is? Somebody didn't think about that. Someone consciously removed one and not the other. And we're going to find, I'm sure, dozens and dozens, if not hundreds of those kinds of things as we train more and more systems.
Yeah. I think that's totally true. And that's really why it's important to get more users into our data sets, but then also to start thinking about the millions and millions of people that are not online right now. I mean, there's a large portion of our planet, the world, of human beings on the world that are not on the internet right now. From whether or not they're facing a disaster, like Puerto Rico, or they're just actually not online, like a rural area in Africa. They have smartphones, but maybe they don't have the full access to internet like we do. And there are many populations in our world, if you think about like the rainforest areas or anything like that, that don't have access to the internet. And then that means that our human experience really hasn't fully been captured by the world and by the internet, by social media. And so we probably don't truly understand how rich our lives can be and how much more information that we're missing, things that we don't know, that can be captured by our technology experience. And so that's something to keep in mind as they start to come online, as we start to see more of these communities come online. We might have holes in our products that can't serve them. And they're the best people to know, how these products should be designed to serve and to include their communities as well.
That's really great. Yeah, I hope that we make machine learning algorithms that work not just for the people who have connectivity, but for the next billion that come after them that may not necessarily look like you and me.
Exactly.
Great. Well, thank you so much for chatting with me today.
Thank you. It's been great. It's really fun.
We've been talking with Camille Eddy, and this has been another episode of Hansel Minutes. We'll see you again next week.